Lesson: Monitoring AI model performance in real time. Monitoring AI model performance in real time is an essential component of AI deployment and maintenance. It ensures that models function as intended, providing accurate and reliable outputs while continuously adapting to new data and conditions. Real-time monitoring facilitates the early detection of performance degradation, allowing for timely interventions that prevent costly errors and maintain the integrity of AI systems. This lesson explores actionable insights, tools, frameworks, and methodologies for effectively monitoring AI models in real time, providing professionals with the knowledge and skills necessary to implement these strategies in practical scenarios. The fundamental approach to AI model performance monitoring involves the implementation of a robust monitoring framework that encompasses data collection, processing, analysis, and visualization. One widely used framework is Prometheus, an open-source monitoring solution that provides powerful querying and alerting capabilities. Prometheus collects metrics in real time and stores them in a time series database, enabling users to analyze historical data and identify trends. Through its flexible query language, Prometheus allows users to create complex queries to extract meaningful insights into model performance. Moreover, Grafana, a leading open-source visualization tool, can be integrated with Prometheus to create interactive dashboards that provide a comprehensive view of model metrics. Monitoring AI models in real time requires a focus on key performance indicators such as accuracy, precision, recall, and F1 score. These metrics provide a quantitative measure of model performance, allowing practitioners to assess the effectiveness of their models under varying conditions. For instance, a sudden decline in precision may indicate that the model is generating more false positives than expected, prompting a review of the underlying data and model parameters. In addition, tracking latency and throughput metrics can provide insights into system performance, identifying bottlenecks that may affect real-time processing capabilities. Drift detection is another critical aspect of real-time monitoring, addressing the challenge of changing data distributions over time. Data drift can lead to a deterioration in model performance if not detected and addressed promptly. Techniques such as the Kolmogorov-Smirnov test and the Population Stability Index are commonly used to detect changes in data distributions, enabling early intervention to recalibrate or retrain models. Implementing automated drift detection pipelines ensures continuous monitoring and rapid response to changes, minimizing the impact on model accuracy and reliability. To illustrate the effectiveness of these monitoring strategies, consider a case study involving a financial institution that deployed an AI model for fraud detection. Initially, the model performed exceptionally well, but over time the accuracy began to decline. By implementing real-time monitoring using Prometheus and Grafana, the institution was able to track key performance metrics and detect data drift early. The insights gained from these tools enabled the institution to retrain the model with updated data, restoring its accuracy and maintaining its effectiveness in detecting fraudulent transactions. This case demonstrates the importance of real-time monitoring in identifying and mitigating performance issues before they escalate into significant problems. In addition to technical tools, establishing a culture of continuous monitoring and feedback is crucial for maintaining AI model performance. This involves fostering collaboration between data scientists, engineers, and business stakeholders to ensure that monitoring practices align with organizational objectives. Regular review meetings and performance audits can help identify areas for improvement and ensure that models remain aligned with business goals. Furthermore, leveraging cloud-based platforms such as Amazon SageMaker and Microsoft Azure Machine Learning can streamline the monitoring process by providing integrated tools for data collection, analysis, and visualization. The integration of automated alerting systems is another practical strategy for enhancing real-time monitoring. By configuring alerts based on predefined thresholds, teams can receive notifications of performance anomalies, allowing them to take corrective action promptly. For example, setting an alert for a drop in model accuracy below a certain threshold can trigger an investigation into potential causes, such as data drift or model parameter changes. This proactive approach ensures that issues are addressed before they impact business operations, reducing downtime and maintaining customer satisfaction. Real-time monitoring also plays a critical role in ensuring compliance with ethical and regulatory requirements. As AI models increasingly influence decision-making processes, it is essential to monitor their performance to prevent unintended biases and ensure fairness. Implementing fairness metrics, such as demographic parity and equal opportunity, alongside traditional performance metrics, allows organizations to assess and mitigate bias in their models. Regular audits and reviews of model outputs can further ensure compliance with ethical guidelines and regulatory standards, fostering trust in AI systems. In conclusion, monitoring AI model performance in real time is a multifaceted process that requires a combination of technical tools, methodologies, and organizational practices. By leveraging frameworks such as Prometheus and Grafana, implementing drift detection techniques, and fostering a culture of continuous monitoring, professionals can ensure the reliability and accuracy of AI models in real-world applications. Additionally, integrating automated alerting systems and compliance monitoring further enhances the effectiveness of real-time monitoring, enabling organizations to maintain high-performance AI systems that align with ethical and regulatory standards. These strategies not only improve model performance, but also contribute to the overall success and sustainability of AI initiatives.